which that would override that. So since we have Liam here, I thought it would be great for him to give a great explanation about validators and how that's going to work. Maybe talk a little bit more about consensus as well.
Yeah, totally. So as Christine mentioned, one of the things we really want to create is a great experience for developers. So on the demand side, she kind of explained like what you're getting. And fundamentally, it looks a lot like AWS, but for Web3. That's really powered by a decentralized validator set. So the way both nodes work in our network is there's a couple requirements you have to fulfill. So you come in as a validator, and there's a staking requirement, which allows you to provide sort of like the economic security for the network, and then there's a technical requirement. And you could do this as many times as you want, as long as you meet the requirements for each node. So we really take a step back and remove all the jargon from it. Validators all over the world are providing servers to the dApps. And the way our network works is when you join, you basically join the bottom part. You're in this sort of Scale network as a validator. And what our protocol does is it randomly assigns, in the default spec, 16 validator nodes to support your S-chain. But 16, doesn't sound like a lot. What happens is there's also security guarantees around sort of rotating mechanisms where nodes may do work for an S-chain, for a couple epochs or longer, but then as time goes on, they're sort of rotated in and out. So what we're really trying to abstract away is, as a validator, you're not worrying about competing on stake. You're not competing for delegation and try to get the biggest weight in the network. You're simply providing servers to the network and working for dApps. And through our protocol, you're sort of rotated in and out, and that we find creates a better experience on the dApp side. But on the validator side, economically, it's a more fair model as well. Right? So one of the things we care a lot about is decentralization, and one of the biggest things we think about is a network really decentralized if 5 validators control, let's say, 60% of the network, or 70%, right? To us, the answer is clearly a no. So we've created a system that allows many validators to participate, and even if you did want to spin up more nodes in a network, at least you're providing more servers and computation to the network, which we feel is a more fair model.
Thanks, Liam. So that's a take from the validator side, but I did see that there were a few developers in here that wanted to understand how the network worked for them. So how this looks like, and I will give a demo of the product working as well, that Scale chain that you spun up, you still have access to Ethereum. We're not saying move your tokens to our network. Instead, what we're saying is keep your connection to Ethereum because your tokenization of your ERC20, ERC721 contracts are valuable. But instead, move your computation over to Scale. But one of the things that we do differently is we provide a mechanism called interchain messaging that still allows you to connect back to Ethereum. Now, what that means is that instead of moving your tokens to Ethereum, what we do is we create a deposit box. That deposit box lives on Ethereum and tokens never move off. Instead, we create clones on the Scale chain side that creates a pointer back to Ethereum. So as you can imagine, as you're transferring the token between one user to another, at the very end, someone's going to want to exit. It's only at that moment you have to incur that unnecessary gas to then be able to send the token back to Ethereum, burn it on the Scale chain, and release it to the new owner. So if you're using a product like OpenSea, obviously they can then suddenly start to trade that within the marketplace. Now, for dApps, again, one of the things that we did is we didn't want to have you learn new technology. You've already spent so much time learning Solidity, why change that? So, if you built a smart contract, but let's be honest, it's never just one, it's multiple. All of those you can deploy directly to Scale using existing tools. If you can build a truffle, you can use that. If you're building your own deployment system, you can still use that. The only thing you have to change is where you're pointing your smart contracts to. And that's an endpoint that will provide to you to access your Scale chain. Now, again, because you still want to maybe exit those tokens back to the end user, eventually you'll be able to still connect back to Ethereum and send the token back. So let's make this a little bit more fun and show you the demo of the product. So I'll move the chair over. Okay. So here I have a dab. It's a fun game called rock, paper, scissors. If you haven't heard of it, paper beats rock, scissors beats paper, and I think rock beats scissors. All right, I got it right. So I want this to be interactive, and I would love for anyone to play with me, maybe reach consensus and figure out a move all together. But what we're doing is we're connecting to Rigby via MetaMask. Now this is another friction point that I'm sure you have all seen for your users. But we're going to use it anyway, and we'll talk about usability in a moment. But on the Rigby network, I have my smart contract deployed there, and this game links to it. So who wants to pick a move? Rock, there we go. Okay. So if I pick rock, what will happen is MetaMask will come up, a process we're usually familiar with. But one of the things you're going to see here is that the user has to pay gas for simply just selecting a move. Now, why would you want to do that to an end user that simply just wants to use the app? It doesn't make sense to have them constantly approve a transaction, but we're going to do it anyway, just for fun. So if I confirm this transaction, it's going to go to the Rigby network. And some of you that have done development on Rigby knows what happens next. We're waiting. And we're all going to wait here together until it finally finalizes, and that could be 45 seconds, it could be a minute, it could be longer. But the problem here is that now I've turned a game into something that is kind of like a waiting queue. So we lost, rightfully so, because we had to wait for it. But if I go ahead and play again, let's try to switch it up and speed it up by using Scale. So to do that, I want to show you the documentation so you can see what it takes to get up and running with Scale. It's a really easy process, and I tried to narrow it down to just 3 steps. You get your Scale chain, you migrate your smart contracts, and you send transactions. But if you notice here in the middle, who here has used Truffle or heard of it? Okay, perfect. So similar to deploying to Ethereum on Truffle, you can deploy to Ethereum by simply just pointing where you're going to deploy the smart contracts. So because we do have developers in the room, I'm actually going to show you this in code. So here, I'm going to go ahead and give my endpoint a name, cheat a little bit because I already got a Scale chain from myself. Paste that there. Let's close it out properly. And then what you see here is I already have a couple of networks for deploying locally into Rigby. A familiar process if you're familiar with Truffle. But to use Scale, it really is as simple as copying what you've already done with Rigby. Of course, making a few changes so we're pointing to the right location. And I'm going to go ahead and save that. But if I take it a step further and come here, let's go ahead and run that deployment to see what that looks like. So again, developers in the room, if you deploy to Rigby, it's another waiting game. Usually, when you deploy this, what you have to do is wait 15 minutes or more. If you have a really complex smart contract and there's an error on deployment, guess what? You have to restart that 15 minutes. And that is a headache if you don't have time or you just want to go to sleep because you've been coding all day. So one of the things you're seeing here is that instead of deploying one smart contract, wait 10 minutes, deploy to the next, it's going extremely fast. So literally within a matter of seconds or a couple of minutes, depending on how complex your smart contracts are, we'll have this deployed. So we'll give this a few more seconds. Looks like we're almost to the last one, which is the game rock, paper, scissors. Get that deployed. Perfect. And then what we'll just do is restart the application. So while that's restarting, again, I really want to highlight the simplicity here. We didn't have to learn a new language or learn a new deployment script or anything like that. Instead, we're using the exact same tools, Web3, Truffle, deploy. And all you need from us to get started is one piece of code, which is that endpoint. Now, if I come over here, and let's go ahead and change a MetaMask to point to Scale. We'll continue to use the MetaMask for now, and eventually we'll talk about just a little bit more usability. But let's pick another move. Someone else want to pick something? Scissors? All right. Cool. We reached consensus, by the way. I heard multiple people say that. So. Okay, before continuing on, I want to draw your attention to the transaction costs. What you see here is that it's 0. A user should not have to pay for transactions that just don't make sense. Just like AWS, where you rent space and you decide how much you want to charge a user for your product, you have the same leeway here. Now, as you can imagine, when you're sending those tokens back to Ethereum, of course, you will have to charge in the gas because Ethereum charges the gas. But outside of that, we don't charge Ethereum users gas. But let's go ahead and confirm this and see what happens. Now, one of the things you'll notice is that I didn't have to try to fill the time by constantly talk about useless things. Instead, what we could do is actually play the game and see the outcome. It was a tie. But let's play that one more time. And I want to do that by trying to remove another friction point, which is MetaMask. If your users have to download another tool just to interact with your dApp, we're not winning the blockchain space. Instead, we should figure out a way to bring everything internally. So yes, it adds more work for the dApp developers, but when you talk about usability for end users, they will greatly appreciate it. So what does that look like? Well, at Skale Labs, we try to build quite a few partnerships, and the one that we've been trying to go down the most recently is API-based wallets. So if I head over here to integrations, Portis is the most recent one that we added, and the reason why I'm going to highlight them today is because they added a new feature specifically for sidechains, and it's called Trust My App. Trust My App means that for transactions that have 0 cost, your end users, they don't have to click a button to say approve because it just doesn't make sense. Instead, they can determine that I trust this application, I use this every day, just process my transactions unless there's a cost, which makes sense for most users. Now, one of the things you'll notice here is that just like that truffle deploy, the only change you have to make for using this tool is a Skale endpoint, nothing more. So I won't bore you by showing you the code because we don't have all developers in the room, but instead what I'll do is show you the outcome. So instead of having MetaMask do the work, we have this sign in button up here. Now if I click on that, what it's going to do is it's going to connect to the Portis network, and here it's going to allow me to log in with just something that people are familiar with. I use my email and I create passwords all the time, so this is familiar to me. I don't have to be, weighed down by understanding what a wallet is just to use a blockchain. Instead, I can offload that to Portis. But let's say that I am curious. I still have access to all of my data. I'm not losing that at all. But I'm going to go here, close this out, and let's go back to the game and see how that works. So one last time, please play, someone. Thank you. Okay, so I'm going to click on that and just wait for Portis to do its thing. But you see what it's done in the background. It signed the transaction. I didn't have to click something. I didn't know that I had to approve. Instead, I can play the game. So what you saw here, and it actually worked out beautifully. I didn't plan this. We lost for Freaky. We had a tie with the Scale. But now we're winning. We're winning the blockchain space, guys. And that is because we're really thinking about usability. And to me, scalability and usability are synonymous, meaning that if you can scale your dApps by using a layer 2 solution, do it. There's no one size fits all, so please explore them all. But if you can do it a little bit further and try to really make usability a thing for your end users by adding in simple things like API-based wallets, do that as well. So that's all I wanted to show you today. But if you have any questions, please let us know.
If there is no transaction fee, then how do you incentivize those validators besides the fuse token generated?
I'm going to pass that over to Liang because he does with pricing quite a bit.
So, great question. For validators, there needs to be an incentive. We have 2 types of incentives in the Scale network. One is like more of a bootstrapping mechanism or an inflation rate that's like pre-minted or predefined, and you kind of run the math yourself. The other one is if you think back to how you would, if you and I were building a startup and we needed infrastructure, you pay a subscription fee, right? You say I need something of this size for 3 months and my monthly rate is that. So what you do as the developer is you're buying a scale chain. And then you could choose how the experience you want for your users are. So at the end of the day, the incentive really comes from the idea that people use Scale, one, through the validators get the inflation rate, but then they also get the network fees as well. And one thing I will highlight about the fairness part is validators, since they shuffle, it doesn't also make sense for you to say, I want to support Christine's DApp versus my DApp, right? Maybe she has a lot of value and I'm just storing documents, right? So what we do is we actually aggregate the fees at the network level and share it based on all performing validators. Does that answer?
Yes.
Great.
Oh, we got another question here.
Is there a real blockchain running in Scale network, or you're just providing a middleware to run the DApp?
Yeah, great question. So to repeat the question was, is there a real blockchain running behind Scale, or are we just processing the transactions? Is that it? Yeah. So yes, there is a real blockchain running behind Scale, and that's built by our decentralized network that Liang is working on building. So that decentralized network runs basically a version of EVM, which is what allows you to deploy your smart contracts to Scale and have it work through our in-house consensus protocol. So it's a proof of stake, different from proof of work, but we didn't create new math. So instead, with our consensus protocol, we have the white paper release as well as a really great blog post if you want to really understand the deep math about our consensus protocol to explain what that looks like. But some of the things that we added in was something like bailless signatures, just to add another layer of security when it came to finality. So, any other questions? All right. Well, thanks so much for having us. If you have any other questions, please come back.